I'm done prototyping my controller, and last time I already had some rudimentary software in it which allowed me to test out the OLED and the keypad, the LEDs and stuff. But now I have a finished software in it, and let me show you its features. Sorry, just saw a slingshot channel video. Couldn't resist. So, what does that thing do? So, when we start up, we have an elapsed time of 0, of course, and a set time of 3:15. That's obviously not hard-coded in the code, but that is stored in the EEPROM of the Arduino. And I can edit the time with my up-down, left-right buttons. So decrement, increment the minutes and change the digit and decrement here. And if there's an overflow, yeah, it will decrement and increment the next digit, and yeah, same here. And of course, as soon as my value is no longer the same as stored in the EEPROM, the colon will blink too. Just as a reminder, no problem, I can store this value with the black button, the store button, inside the EEPROM. Now the value is stored in the EEPROM. Change it and read it from the EEPROM. But the default value is read on startup from the EEPROM. Let me put that back to 3:15 and store that. Yeah, then we have here the traffic light. Green is run. There's the yellow LED which is coming on, and also the UV LEDs, of course. I can stop the whole thing. Yeah, that's the stop button. Everything's off again. But I also have the option to run something. And yeah, it started from 0 again. And to pause it. Yeah, LEDs off again. And then resume. LEDs on again, of course. I hate this 1 or 2 button Chinese user interfaces. I wanted a really nice user interface. And I wanted to see, not as a countdown timer, because I'm not interested how many seconds I still have to expose the board. I want to know, let's put that on pause mode or on stop mode. Yeah, from pause you can directly go to stop. I want to know how many seconds it actually has been exposed. And I want to see and have stored in my machine the exposure time. And of course, I want to be able to change it. So yeah, that was my requirement. And lots of buttons, because yeah, I could. So what I want to do now is go step by step. Yeah, let me reset the whole thing by turning it off and on again. I want to go step by step through the code, which enables all this functionality. And of course, you've seen we switched it on and it comes up in a defined state. So how is that working? Let's have a look at that. Let's get the boring stuff out of the way. Every C++ program, you start with some includes where you include all your libraries. I need keypad and wire. And keypad for the keypad, of course. Wire is required for my OLED library I'm using, which is 2 includes. I'm doing some EEPROM stuff in the Arduino. That is, I'm permanently storing a value. We'll see. And I need standard I/O for a function that's called sprintf, which is an established way to format numbers into strings and stuff. And yeah, it makes nice, more compact code compared to yeah, the C++ method stuff. But that's a question of taste. So I have a lot of declarations. I have editor declaration, at least one. Digit edited. This can be between 1 to 2. And you saw I have 3 digits. One is blinking, and that's currently the digit 1. So my leftmost digit. Then I have my status declarations. My whole controller revolves about 3 main states. And that is, it is either stopped, doing nothing, that is not exposing, or it was paused, that is it ran and then it goes back to the pause, or it is actually running. So basically this models my state machine, which does the overall control. And of course you could do these 0, 1, 2 also with double, yeah, we have a with a defined statement, but this allows the compiler to do a little bit more type verification, type control. Okay, so stop, pause, run, just so it's out of the way. We start in the stop state. From the stop state we can go into run. From run we can of course return to stop, or we can go to pause. From pause we can of course resume running, or we can directly go to stop. So that's my state machine, and we will see a whole lot of big case statements modeling that later on. So run states, I have a set status, that's my desired state, which comes from the keypad, and this is initially stop. And I have a run status, that's the actual state, and this is at the beginning also stop. And one Arduino hardware definition, my operate pin, that is a pin which switches the UV LEDs on and off. Yeah, that's A4. Then I have a whole bunch of keypad declarations, and I won't talk about those. Right now have a look at that video where I did the Arduino keypad library, yeah, card link. I won't talk about the OLED declarations in detail, just, yeah, again, card link. I have a Watchdog declaration, that is my Watchdog is running out of pin A5. And now I have a whole lot of timer declaration, which is just, yeah, I fumbled around with different fonts, and at some point I got tired of changing all these numbers in all the code all the time. So I put them into constants. Const declaration again is an alternative to the defined declaration, giving the compiler a chance to actually do some type checking. Yeah. So normally const is preferable to define. Yeah, what we have. My maximum time is 599 seconds, which I can display, so 9 minutes 59 seconds. My time format, and this is used for the sprintf, is 1 digit unsigned and then 2 digit with leading 0 unsigned. We will see how that works in the sprintf. My time row, and that's a display thing, is 1. So my display basically has, when that's the OLED display, it's divided, and that's just the library I'm using, into 4 rows, 0 to 4. Each has 8 columns. So my time is down here. Okay, and time row height is, of course, 1, 2, 3, 3 columns. Time call run, that's the column, and these are, interestingly, 0 to 127. So my time area starts here at column 1. My set time starts somewhere in column 27. Yeah, so here I'm displaying the set time, and yeah, there is a little gap here. Here I'm displaying the runtime. My width of the jars I'm using, this is a fixed space character set, is 14 pixels. Yeah, and then I have an unsigned int time set. That is the set time I want to expose. That's 0, and I have a time that is stored in the EEPROM of the Arduino. And that's also 0. The setup routine does a lot of redundant stuff. So for the editor, I set the digit edited to 0 again. I already initialized the variable to 0. That's called defensive programming. I mean, you're bound to make errors, forget to initialize a variable or something, and yeah, doing things twice doesn't hurt unless you are on a quest for absolute performance, which we are not in the setup routine. Keypad setup, again, watch the video about that. Important command, this is not an interrupt function. You can add a listener, which I did, to the keypad, but you still have to poll that keypad object. Yeah, more about interrupts later. My Watchdog setup is simple. I set my Watchdog pin to output and set it initially to false. That's equal to low, but since I'm using later on booleans, yeah, these booleans, false, true, are interchangeable with the high-low macros provided. Status setup, again, redundancy. My actual run status I'm in is stop, and my set status, the status I should be in, is equal to the run status. Pin mode for my operate pin, which controls the UV LEDs, initialize output, and it's of course initially low. The timer setup is a little bit more interesting. So first of all, I use the EEPROM object of the Arduino with the get function to the address 0 inside the EEPROM to read the last time EEPROM I stored. This time I'm getting it, I'm reading it. Then I compare or check if that time in the EEPROM is actually makes sense, so it's not some random value beyond I can handle. So my time max, that was 599 seconds. And if that's the case, my set time will be the EEPROM time that I stored in the EEPROM. If that's not the case, my set time is 0 and my EEPROM time will be the set time, which is 0, and I will put that back at address 0 into the EEPROM. Just to clean it up. If you put that on another Arduino, there might be some stuff already stored in the EEPROM. And you will see that I tried to minimize the put operation on the EEPROM because that's a part of the Arduino which ages. So the EEPROM has only a limited number of write cycles for each cell. So I try to minimize the writes. The OLED setup, the stuff with wire and so on, look at the OLED video. I make an OLED clear at the beginning. What else? I set my font, which is the LCD 5x7. And then I write in the time column. Now I have to add row 0. You remember that picture, row 0. I have here some space and the runtime column was here. I write an elapsed, and then here at column 27 I write set. And I only need to do that once in the beginning. Elapsed, and then in the time column for the set time, set. I switch to my big LCD nums, 14 by 24 pixels, and then I print out, and this is a function we will have a look at later, or let print time into the column for the runtime, call run 0 seconds, and into the column for the set time, the time set, which we already initialized up here. Now within the Arduino loop statement, which is repeated over and over and over again by the Arduino firmware, I have a so-called static variable, static unsigned long, last display and timer update set to 0. Static means, and that's a way to, in a microcontroller environment, to avoid too many global variables. Global variables are not never, but generally not a good idea. But the static statement before the variable causes that variable to survive between calls of the loop function. Keypad is simply a keypad get key statement, and that's polling my keypad as often as possible every time the loop runs through. Timer and display, I compare the difference between millis and that variable last display and timer update 0. If that's greater than 500 milliseconds, so half a second, I update my last display and timer update variable, and then I call that update display and timer, and that's one of the call functions, and I call it only every half second. And then I also call the watchdog. And the next time, let's say millis was 500 exactly, and I set last display and timer update to 500, and the next time loop is entered, the variable will not be initialized with that value, but it will still have the value of 500. And then I go through the loop until millis minus 500 is again greater or equal 500, so I wait for another half second. That's how these static variables work. They are initialized only one, and they keep their value even if the function is finished, until the function is called again. Yeah, let's continue with the watchdog. The watchdog function also uses a static Boolean watchdog output, which is initialized to false. And each time the function is called, as often as possible, the watchdog output is inverted and then simply written out to the watchdog pin. Card link to the watchdog video, how that works. And then keypad event, but we do that in a later point, because at the moment we don't have a keypad event because I haven't pressed the key. As I said, we go through the code as it's actually executed. The update display and timer function actually does something. I mean, it's called every 500 milliseconds, and you remember one-digit blink. This is just a graphical overview over the update display function, which basically breaks down in 3 sections. Right at the bottom we will see that I do some clean up work, toggling stuff. Then I have one big switch statement with 3 different blocks, which handles the 3 different states, what to do inside these states. So this would be my, we're stopped, we're paused, and we're running. Okay, and the top section is a case statement inside a case statement, which is only executed if we want to change the state. That is, if a button is pressed run, stop, or pause. And this also is divided into an outer case statement, which represents our current state. So we are in the stop state, in the pause state, and in the run state. And I'll zoom in. And inside these states, we are handling, again in sub-switch statements, the desired states. Here from stop, we only go to run. When we are in pause, we can go to stop, or we can go, stop, run, pause. When we are on run, we can go to stop, or we can go to pause. And when we are in pause, basically the same. We can go to stop, or we can resume to run. And it also starts with 2 static variables. So the Boolean intermediate is set to false. I call this update and timer every half second. Every other call, I just do blinking stuff, or when intermediate is false. I actually update, if it's running, my counter and stuff. So count up the exposure time. The first part is if the set status is not equal to the run status, which it is not at the moment, so we can skip that whole section. After that section comes a really big switch statement, which handles the current status, that is my run status, the status I'm currently in. Okay, I have a status run, and this is the run status. Not pretty, but yeah. We are actually at the moment in the status stop. And if we are in an intermediate call of the function and the EEPROM time is not equal to the time set, then I'm actually and again, I will talk about that OLED functions later on, an OLED clear time colon. So I will erase the colon, or I will blink the colon in the set time. I always clear the digit which is currently edited, in the set time. So in the intermediate state, I only do the blink. When I'm not in the intermediate state, I simply redraw or print again out the set time onto the display. And that's actually, the rest is currently not active, so we talk about that later. That's actually all that's executed by that update function. Not quite. Actually, at the very end of the function, I set intermediate to not intermediate. So when it was initially false, it's now true when I exit the function. If it was true, it will be false when I exit the function. And remember, that was a static variable, so it will keep that value until the next time the function is called. So we know now why there's here initially 3 minutes 15 seconds, because it was stored in the EEPROM. And I have here a left and right button. And if I press it, I change the digit that can be edited. Yeah, let's have a look at the code for that. So you remember in the setup, we add that keypad event function as an event listener to that keypad object. And in the loop, we make the keypad object poll the keypad as often as possible. Just to give you an overview, and don't worry, you don't have to read that now. I just want to give you an overview over the structure of my keypad event routine, and we will zoom into the different sections as soon as we use the functionality. So basically it's one big switch statement. You cannot read it, but it's a switch statement, and depending on in which run state, actual state we are in, we are executing different sections. And we will have a look at each sections. And within each sections, we basically take, depending on which switch, here that always says switch key. Depending on which key is pressed, we do something different. So these are these blocks. And that keypad event procedure gets, when a key pressed, the key passed, and then I test if the key state is pressed. I'm not doing automatic key repeating if you keep a key pressed. And then again, I switch according to the run status. And we are currently in the status stop. Here I switch according to the key that is pressed. And we just have these two lines here at the top, which were active. So if I press the left key, my digit edited will be decremented by 1. This is this funny C++ statement. So this is a condition. If my digit edited is still greater or equal 1, then this will return 1, otherwise 0. So if I press that button, the left button, this will be decremented by 1. And if I press the right button, it will be, similar statement, only this time I'm testing if I'm still smaller or equal to 1, will also be incremented, by 1. This is basically done because I only have 3 digits. So this statement will block as soon as I reached 0, so the leftmost digit, and this will stop when I have reached the rightmost digit, number 2. So this is all what we did right now. And remember, in my update statement, I'm blinking the currently edited digit. Back to the real world. Okay, so right and left, but I also have up and down. Here I can increment in minutes or increment in minutes, increment in tenths of seconds, or decrement in tenths of seconds, and this will, if I reach 0, overflow into the minutes, and the same here. And you notice that now also my colon is blinking, unless I go back to 3 minutes and 15 seconds. So that blinking colon, if I change that value slightly, gives me an indication that my current value is not the value that is saved in the EEPROM. So let's have a look at the code for that. So again, I'm in my keypad event handler in the status stop, and now I press the up and down keys. And depending on the digit I enter, either if I press up, the time is incremented by 60 seconds, 10 seconds, or 1 second, depending on which digit my cursor is, or the time is decremented. Also by 60 seconds, that is a minute, 10 seconds, or 1 second. And I only do that if, I'm not exceeding my maximum time of 599 seconds, and I won't go below 0. So for example, time set has to be greater or equal 10, so I can decrement it by 10. The time has to be smaller or equal my maximum time minus 60 seconds, so I can add another 60 seconds. So depending on the switch, this is basically the increment and decrement. And we are back in the update display and timer function. which, yeah, we already talked about it, which simply updates the time, the here, the time set, which is incremented or decremented by the keypad routine. Yeah, and of course it blinks the colon also, not only the digit edited, but the colon also, as soon as the time stored in the EEPROM is no longer equal the time that we have set. Okay, back to the controller. Of course, I can change the time, say to 3:30, and I can write that to the EEPROM. Yeah, stopped blinking. And as soon as I change that back to 15, it's blinking again. And of course, I can read my value stored in the EEPROM also. But not that I forget it. Let's go back to 3:15, which I plan to expose next time, and store that to the EEPROM. Yeah, let's have a look at the read and store code. Back in the keypad event procedure, which still in the status stop, if I press the S key for store, and yeah, if actually the EEPROM time is not equal the time set, then I will set the EEPROM time to the time set and write the EEPROM time to the EEPROM. And only if there's really a difference. So I really try to minimize, and that's the only reason time EEPROM exists, that global variable. I really try to minimize the write operations to the EEPROM. And if I press the read button, then my time set will be set to the time EEPROM. So the code overall makes sure that whatever is stored in the EEPROM is in the variable time EEPROM. Now we want to see, and we can have a preview, what happens if I press the big R key. R for run, which I can also do in the stop state. My set status will be set to status run. And we'll have a look at that right now. So green would be my run key, red my stop key, and yellow my pause key. And if I press the run key, yeah, can you see the LEDs? There's a yellow one. If I press it, yeah, my UV LEDs also switched on, and my elapsed time is counting up. And yeah, we can let that run in between and have a look what the code did when I pressed that button. So actually quite a lot of stuff was happening. We already seen I set that set status in the keypad routine to status run. So my set status, when I go into the update display and timer, is suddenly no longer the run status. And so we fire that first. We haven't had a look at it. We skipped it the first time. We go into that switch statement, which switches according to the run status first to, yeah, we're currently in status stop. And it's not that much code. So if I was in the status stop and my set status is status run, then I will of course go from the run status from status stop to status run. My runtime, my time run, will be set to 0. Yeah, we just were stopped, did nothing, we started. And I set that intermediate flag to false. That means when the code afterwards is executed, it will automatically not do the delete clear OLED actions, but the print OLED actions. And what I do here one last time, I print the actual set time because yeah, the digit might just have blinked and is invisible. So I print the whole thing out again, the set time to the right. And then I set my operate pin, which controls the UV LEDs, to high. And further down in my update display and timer routine, of course, we are no longer now have the run status stop, but instead we are going further down the case statement and are now in the status run. And this does first when we are in the intermediate, so half second step, it clears the colon, this time in the runtime, so elapsed time window. Or if we are on the full second, we print out the current runtime. And if our runtime has reached the set time, we force our run status to stop and also set our set status to the run status, which is stop. So basically we say, okay, time elapsed, everything back to start, that is the stop status. And of course, not to forget, we write low to our operate pin and switch the UV LEDs out. I mean, that's the idea in the whole thing. Otherwise, if we haven't reached the end of our exposure time, we increment our exposure time by 1 second. Yeah, initially I wanted to do that as the whole thing as an interrupt routine. And the keypad also as an interrupt routine. But firstly, for some reason with the Arduino Micro, the timer 1 interrupt library does not work. Second, my keypad is also not an interrupt, but is polling. That might result in some conflicts. So while the keypad is polling and doing some timing stuff, you know, timing stuff for debouncing and so on, this interrupt routine might kick in and then all the timing is off, and yeah. So I just rewrote it on the top level, all for polling. So basically that's all that happened, and let's see what happened to my exposure unit meanwhile. So as you can see, the UV LEDs have switched off again, and my elapsed time is 3:15, and I'm back in the editor for the set time. We saw it in the code, if after the time is elapsed, I switch back to the stop state, and yeah, we already know what's happening here. And we do the same again. Yeah, yellow LED. I start again, expose again, and this time I press in between the stop button. Okay, so I can stop in between. We are now in the stop modus. We have some elapsed time, and yeah, but if I go to start again now, it starts from 0 until the set time. So stop. How does the stop button work? We're back in the keypad event procedure, but now in the switch statement for the run status a little bit further down. And here we are, currently we set in the status run, and depending if I press the pause or the stop key, and we just press the stop key, everything goes to set status, status stop. And yeah, the keypad event really sets only the set status. We have to look into our update function to see what's happening. This is all done by the update display and timer function, and we are here at the beginning again, and now our set status, because we pressed the stop key and we were running, is no longer equal to the run status. So we enter this switch run status statement, and we are currently not in the status stop, but we are in the status run. And when we are in the status run and the set status we want is the status stop, then we set, of course, our run status to stop. If we are not in an intermediate call, then a full second has passed. Yeah, since the last call of the function, and so we add a second to the runtime. We force intermediate to true, simply to blink the digit next time of the set time to the right. We redraw the elapsed time because maybe a digit there was just blinking and not visible. And of course, we write a low to our operate pin. And that's all. The rest, we are again in the status stop. We already seen the code. And if you remember what we done so far, we went with the key from stop to run. So in our state machine, this path, we did that with the keypad. We returned from the run state via a timeout. So our elapsed time reached the set time to the stop status. And we went also from the run status via the keypad to stop. So the rest is easy. What I wanted to have was, if I run the whole thing, UV LEDs are on, that I be able to pause. And now we are not in the editor. That doesn't work. We are still exposing, but we have stopped our exposure. Let's see what happened when I pressed the pause button. So in the keypad event, I'm now in the case statement further down. We were in the status run and we didn't press stop, but pause. So really primitive. My set status is status pause now. And in the section handling state changes, my update display and timer routine, I want to switch to the pause status. I'm in the run status and I want to switch to the pause status. So my run status will be the pause status, and like for the stop status, I check if the function is called on the full second and will increment the total exposure time accordingly. I will set then force intermediate to true, so I will blink this time, not my set time, but my elapsed time. You see the whole display was blinking. And of course, I write low to my operate pin. And further down in the second case statement that actually handles the current status. Here I now in the pause state, and this is this is really simple. I clear in the OLED my runtime, so from this basically column 0, that constant, in intermediate, so on every half second, and on every second I print it. And I showed that already from the pause state we can resume the run state. Yeah, UV LEDs are on. And I put that back in pause so I won't get a sunburn. But we have look at the code, what happens when I press the run key again. So we are in the keypad event switch statement. Again, our current status is pause, and now I pressed the run button again. So our set status is status run. And accordingly, our update routine, I'm here in the uppercase statement handling state changes. We were in the pause state and now we require to go to the run state again. And yeah, there are some exception handling here, because if our runtime is already our set time, so yeah, we reach the end of our exposure, we might have hit the pause button just in the right moment. So in that case, I will go immediately to the run status stop and set my set status also to that run status. Force intermediate true, so I will, because I'm going to the stop status, will immediately blink on the right hand side the digit being edited, and I will redraw the runtime, the elapsed time, in case a digit was missing here or it was not, because we were pausing and blinking the whole thing. Nothing was displayed at all. In all other cases, our run status will resume as run. I also force intermediate true for blinking purposes, and I will redraw the elapsed time again. So pretty much the same as above. Plus I will of course set the operate pin to high, switch on the UV LEDs. And if you look at our state diagram again, so we went from run via the keypad to pause, and also via the keypad back to run. And we had that exception handling, which I will not try to show you in real life, because I would have to time pressing the button. This is really an exception, pressing the button in the right moment. We also had, yeah, we pressed the button, but then our update and timer routine decides to make a detour to the stop state. So only one thing left. We are on pause, and of course from pause I can also go to stop. So we left the thing in the pause state, and yeah, I can press stop. So time elapsed will still be shown, but is resetted to 0 if I press start again, and we are back in editing mode. So we were already here in the keypad event, so we were in the pause state and now pressed S for stop. So we said set status is stop, and yeah, same state switch statement here in the update display and keypad. We were in the status pause and now want to go directly to the status stop, and that's really simple. We simply change our run status to stop and intermediate to true, again to force immediate blinking on the right hand side on the set time, and we redraw our elapsed time. Yeah, and we already looked at the stop state, and yeah, that was over the keypad going to stop. And that's all. So I almost forgot about the OLED functions, which are just encapsulating code that would otherwise be repeated over and over again, which is also a good idea to encapsulate such things and functions. And it does some basically pixel calculations here. Where on my display do I have to do an operation? So OLED print time is actually using that sprintf function I mentioned, which prints a formatted string into a buffer, which I have declared here. And you might remember time format is that %1d colon %od means print the first digit of a number, then a colon, and then 2 digits of a number with leading zeros. And my numbers I print, of course, are time divided by 60. So that's my minute. And time modulo 60, that's my seconds, 0 to 59 with leading 0. Yeah, OLED clear time deletes a whole time. I just give it as parameter my time column, so either set time or run time, and the function calculates from which column in pixels to which column in pixels and calls the OLED clear time columns. I will use that function again and again. And yeah, then we have clearing a single digit. I only give again, yeah, in which time column I am, and the digit I want to delete, and do the pixel calculations just for the column and pass that again to that OLED clear time columns. Colon, the same, no parameter because the colon is always at the second position. And then finally I have that OLED clear time columns, which adds and basically to the from two columns the calculations for from to row, and finally calls the original OLED.clear method. That's all. So where will I go from here? Of course, this has to go onto a board, and then that board has to be mounted somewhere in the case. So yeah, till then, bye.